At the moment, the arithmetic series proof is examinable. It hasn't come up very often in the national papers, but yeah, we do need to learn how to do it. And I think it's got value either way. It's really good to know why you're doing what you're doing, and when you end up using the formulas, it's really nice to be able to identify what makes them work mathematically. Okay, so what we're going to do is we're going to follow 4 steps, and then I'm going to take you through how to understand it and finally how to do it. Okay, so the first step is going to be, we're going to write a sequence in ascending order, and these will be the steps to memorize. Then we're going to write the whole thing again in descending order. Then we're going to add them. This makes no sense right now, but it will make some sense later. And then we're going to solve for Sn. Okay, so what that looks like is the following. I'm going to do one that helps you understand it. What I'm doing now is not the actual proof, but it is a way of really helping yourself understand what we're going to do later. Okay, so for example, if I use S4, and I'm making up an arithmetic sequence here, so I'm just saying that we're going to sum to all of those. Obviously, it's the sum to 4 terms. Those are the first 4 terms. My first step was to do it in ascending order. My second step is to do exactly the same thing. I'm going to write this little equation again, but this time I'm going to write it the other way around. So I'm going to do it in descending order. Okay. My next step is to add them. So I'm going to draw a line underneath and add them like we used to do in primary school. And if I have sum to 4 plus another sum to 4, I've obviously got 2 sums to 4 terms. Okay, and then you're going to notice a pattern here. If I add them, I'm going to get 12 every single time. Okay, so that's what makes this interesting, and you'll see when we use variables how this becomes a really cool pattern to observe. All right, so obviously 2 of sums to 4 give me all of those, which actually gives me 4 of the 12s, right? Okay, so that means that 2 sums to 4 give me 48. Okay, which means that 1 of those, so divide by 2 on both sides, ordinary equation style, and that means that I'm going to have the sum to 4 terms will be 24. So what we're going to do now is we're going to use our Tn formula, and we're going to use A and D instead of all of these numbers, and we're going to do exactly the same thing. Okay, so don't do this in an exam if you're asked for a proof. You need to do the next step that I'm going to show you. This is the step to help you understand, and hopefully if you understand, you'll be able to do. A little hack here, this thing takes up a lot of space, so you need to be really, really mindful of how you fit it across your A4 page. Okay, so I'm going to say now, not S4, I'm going to say SN. Okay, so SN, and I'm going to write it forwards. Remember, we do ascending first. And I need to now write it with its variables. So the first term was always A, right? Okay. You'll see I'm going to leave quite a bit of space because I know what is coming. Then I'm going to say, what's the next one? What's the next term? And it will be the first term plus the common difference, right? So my next term is going to be A plus D, right? And then I'm going to add on the next term, which will be the first term plus 2 differences, or this one plus another D, right? So it's going to be A plus 2 differences. Right, now I do my little dot, 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 and I'm going to put in the last 3. So if you think about it, the last one is going to be A plus n minus 1d, right? Because that's the last one, it's the nth term. So I'm going to stick this in here, and you're watching me build it now, because this is how I would do it. I would build it in the sense of I know that that comes last, and I'm going to pop the last 3 in. And for me, this is about understanding how you do it rather than just learning something off by heart. So that's the last term. So the previous term is going to be n minus 2, and the previous one is going to be n minus 3. Okay, so I'm going to just chuck that in here. This is going to be a plus n minus 2d, and then this one's going to be a plus n minus 3d, and you can see I'm quite worried I'm not going to fit it all in, but I have. Okay, so practice just the spacing of that to get it right. And now I'm going to go for descending order. So here I'm going to, obviously that one's going to go there, this one's going to go here. So I'm going to start with a plus n minus 1d, and those two terms are what I'm going to add just now. My next one is a plus n minus 2d. The one that goes under here is going to be a plus n minus 3d, right? Dot, dot, dot. I'm just managing here. And then it's going to be this one, this one, this one. So this one gets added to a plus 2d. This one will be a plus d. And then this one will just be a. All right, so then I'm drawing a line underneath and I'm adding them, and I'm just going to show you which are being added together. So it's these two, right? Those two. And remember how when I did it with 4 terms, they all got to 12. So it's going to be the same now. They're all going to get to the same thing. So don't stress too much. I'm just doing these nasty little red things for your concept understanding. Okay, I want you to know what I'm doing rather than just believe it. Okay, so Sn plus Sn, just like we had S4, gave me 2 of S4s. I'm now going to have 2 of Sn's, right? Okay, now I can add up all of these. But what are they going to be? A plus n minus 1d, that's going to be, okay, 2a's, right? So it's going to be 2a plus n minus 1d. Right, so I've done that one. What's going to happen here? I'm now going to have a plus d plus a, so again 2a, right? What happens here when I go plus d plus n minus 2d? So 1d plus n minus 2d's. Just think that through. N minus 2 plus 1 of the d's. So that's got a coefficient of 1. This has got a coefficient of n minus 2. N minus 2 plus 1 gives me n minus 1, right? So it's going to be the same as this. So it's also going to be 2a plus n minus 1d. And so on and so on and so on. So there are 1, 2, 3, 4, 5, 6 of those. Okay, so that's what I'm going to do. Just going to add them in. Obviously my dot 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 refers to the fact that there would be an infinite number of these. Infinite number? Well, not really, as many as there are terms in the series, right? So clearly there's going to be, in here I've got 6, but how many are there really? There would really be n of them. Okay, so actually this entire thing can be rewritten as n of these guys. It's going to be n of my 2a plus n minus 1d. Okay, so 2 of these added up will give me n of these. Can you see where this is going? It's going to be exactly that formula that you are going to use or have already been using. Going to divide through by 2, but because this is multiplied, I might as well just write it as the whole thing over 2. Okay, so divide by 2, divide by 2. So that means that Sn by itself gives me n 2a plus n minus 1d. Okay, all over 2. The way we like to write this and the way that you're going to get it in the formula, I'm just going to change colors for dramatic effect, is going to be n over 2. So we'll just keep the 2 on that side, and then we will bracket this with a square bracket, 2a plus n minus 1d. And that is the formula that you're going to be using, and that's the proof on how to get there.